Hey guys, today's video is going to be about the vertex form of an absolute value function. And what vertex form means is that we're going to write this function in a specific way that shows us what the vertex is without having to do any math. So I want you to start by completing problems 1 and 2 and A through F all on your own, because this is the same stuff that we learned about in the last lesson. So use your cheat sheet, your graphic organizer, whatever you want to call it, and complete numbers 1 and 2. And you can also use a calculator or Desmos to check your answers, so you can graph them and make sure that you're correct. So now that you have reviewed some of the translations that happen and what they mean and what they do to our graph, we want to look at the vertex form of an absolute value function. And that is written as f of x equals a absolute value of x minus h plus k. Where h comma k is the vertex and a is the slope on the right side and negative a is the slope on the left side. So this is going to make a lot more sense after we get some practice in. All right, so just to remind ourselves, the vertex form is f of x equals a times x minus h plus k. So if we look here, we are going to figure out what a, h, and k are. So a is equal to 1 because there's nothing outside the absolute value, so we can understand it to be an invisible 1. H is positive 2 because since our form has a negative in it, we're going to use the opposite sign of whatever's in the function, whatever's in the formula. Okay, and then k, we keep the same sign. So think k, keep. All right, you're going to keep the same sign. And h, you're going to have the opposite sign of whatever's right here. All right, so our vertex, we learned just now, is h comma k. So our vertex in this function is 2 comma negative 4. So we're going to go right 2 and down 4, and that's our vertex. Now, our right slope, so the slope of the right side, is a, so it's 1. And then the left slope, the slope of the left side, is negative a, so negative 1. So if we use this, this is the same as 1 over 1. So if we do rise over run, and this is to the right of the vertex, we're going to rise 1, run 1. So rise 1, run 1, rise 1, run 1. Okay? And then on the left side, the slope is negative 1. So we kind of think that we should go down 1 over 1, but that's going the wrong direction. We want to go to the left. So we're going to do the opposite. We're going to rise 1 and go left 1. We're going to go the opposite direction. And so we are going to find that our function is right here. And that's it, guys. That's all you have to do for these. So let's do this again. In this problem, A equals 2, H equals negative 1, and B equals negative 2. And I'm sorry, it's not B, it's K. K equals negative 2. So our vertex is H comma K, which in our case is negative 1, negative 2. So let's go ahead and put our point there for our vertex. Then our slope for the right side, right slope, is going to equal A, and left slope is negative A. So our right slope is 2, so that's going to go up 2 over 1. Up 2 over 1, up 2 over 1, and so on. And honestly, we know that absolute value functions are symmetrical, so we don't even have to pay attention to the left slope as much. We can just go in and make them go the opposite, exactly opposite of our right-hand slope. And that's your function. All right, so let's try number 5. We're going to have sorry about that. A equals 2/3, H equals -1, and K also equals -1. So our vertex is H comma K, so that's going to be -1, -1. That's right here. And then our right slope is 2/3. Our left slope is -2/3. So I'm going to do the right slope first. It's rise over run. So you rise 2 and run 3. Rise 2, run 3. Rise 2, run 3. And these are symmetrical, so we're going to just go the opposite direction. Rise 2, run 3 the other way. Rise 2, run 3 the other way. And then draw in our arrows. And we're all done. All right, so number 7 is a piecewise function, and that's okay because we've been doing these already. So we're going to draw our guideline in, and our guideline is just a line that we are going to use to put boundaries, and it needs to go at -1. So we're going to put it right here at -1. And then we're just going to graph both of these, and then let's come back and erase part of it, okay? So instead of thinking about our boundaries too much, let's just even get rid of that boundary. Let's just graph both of these. So we're going to make this one the blue function. So y equals 4x plus 2. That's got a y-intercept of +2 and a slope of 4. So we will rise 4, run 1. And then we'll go the opposite direction. So our function here is, it's going to go like this. Okay. Now we want to do the second part. So the second function, let's make it the red function since I've already written red things on it. So we had to, you need to change this on your paper. Instead of a -3, it should be a -2. So this is absolute value. So we have A equals -2, H equals -3, and K is going to equal 0 because there's nothing added on the outside. So our vertex is -3, 0. So we're going to go left 3 and then up 0. Then we are going to use our right slope is going to be -2 and our left slope is going to be +2. So if we look at our right slope, we're going to go down 2, right 1. Down 2, right 1, down 2, right 1, keep trucking. Okay, then our left slope is just the opposite. And so our function here is going to look like this. But we know that this is a piecewise function. So we're going to go in and we're going to put our line back in, our guideline that we had. We're going to move it to the point -1. And then we are going to erase the parts of this graph that don't belong. So the blue graph only applies if x is less than -1. So we don't need any of the blue graph that is on the right side of our line. So we're going to erase all this guy. And then we are going to draw a circle, an open circle, because it's not allowed to equal -1. So we're going to draw an open circle at the point where it crosses our line. Okay. Now let's look at the red function. So the red function is only applicable when x is greater than or equal to -1. So we are going to erase everything on the left side of our line for the red function. I'm going to have to redraw some blue in there because, this is an iPad, not a piece of paper. Okay, so our red function is allowed to equal 1 or -1. So we will have a closed circle at the point where it equals -1. And then we will draw our arrow the rest of the way. So this is your answer. You don't actually have to include the green line. It's not part of the answer. but this is. All right? I'm going to do one more problem with you. All right, so this problem is an inequality, but it's also absolute value. So we're going to kind of start the same way that we've been going, and then we'll just decide what to shade. So we have A is equal to 1, H is equal to -4, and K is equal to -6. So our vertex is at -4, -6. So we're going to put that over here. -4, -6 is right here. And then the right slope is equal to A, and the left slope is equal to -A. So the right slope is up 1/1, and the left slope is going to be symmetrical to that. So then we can go in and put our line, but if we have to remember on inequalities that if it's allowed to be equal to, then we use a solid line, and if it's not equal to, then we have to use a dashed line, a dotted line. So in this one, we are allowed to equal the function, and so we will use a solid line. Then we have to shade either above or below, and this is less than, so we will shade below. So everything down here is going to get colored in. And that is all for today. I hope you guys have a great day. I hope this helped. Good luck with the other problems.